The paper of the day is a multiprocessor system design. It's a 1963 paper. Fundamental to the concepts presented here is the principle, not yet commonly accepted, that parallel paths in a program need not bear fixed relationships to the processors of a multiprocessor system executing that program. In many applications, if the number of parallel paths generally exceed the number of processors, adding a processor will increase the system's effective speed. This fact emphasizes that there are two research objectives whose fulfillment will render the system design presented here a practical improvement over the present state of affairs. A search should be made for parallelism in commonly used algorithms. The effort of such a search would be greatly reduced by the addition of the equivalent of fork and join to the common publication languages, for example, ALGOL. By the way, this 1963 paper is the first paper to use the term fork and join, which you all are familiar with when you study processes as part of C programming language or operating system. Memories permitting simultaneous access to any set of words should be developed. As long as the memories are slower than processors, simultaneous access is the only alternative to higher memory speed for increasing overall processing rates. Here are some of the properties. A desirable system which flexibly accommodates a collection of identical concurrently operating sequential processors should exhibit the following properties. At every point in time, the number of active processors should be at the minimum of the number of processors in the system and the number of parallel paths in the program at that time. If insufficient processors are available, program paths specified to be parallel should be executed serially. Although the coder must specify all parallelism, he should have little concern about the number of processors in the system at execution time. The means of specifying parallelism should be simply coded and rapidly handled by the system so that for highly parallel programs, the processing time is inversely proportional to the number of processors, subject to the boundary condition that one processor system would run only slightly faster if the specifications of parallelism were removed from the program. Here's one of the highlights of the paper, the storage subsystem. In a system of the type being considered, particularly if its application involves servicing many independent programs, three problems related to the high-speed storage arise. First, complete storage protection must be incorporated in order to isolate several programs. Scavenging and allocation of storage to newly entering programs should not be an expensive process. The effective service rate of the memory should not seriously depreciate the speed increase gained as a result of addition of the processors.